No, I was thinking about just the Venn diagram you showed with just A and B. So if we are not considering A and B, it's outside of A and B, but inside U.
Yeah. Yes. Perfect. Excellent. You were killing transitions today. You were the star wipe of transitions from Microsoft Windows Movie Maker, I think it is the best transition ever. Yeah. That is called, that's our last operation for the day, and that's called a set complement. And just like the not operation, logical operation, the set complement does not take in two sets and give you a new set. It takes in one set. And so the set complement, which we would write as, we say A complement, nice and simple, or complement of A, for example. That is, we write it like this, A with a tiny little c up here. There's A with a tiny little c. This means to take all x in U such that x is not in A. But what that means is note then that A complement really just equals U, not A. Same exact thing. And so in your case, Afra, what you were talking about where you take everything that's not in A, the combined A and B, what you do is you'd say, oh, okay, A union B complement. That's the set you're talking about there. That is, if you had A and you have B, you just take everything that's not in A exactly what that is. Makes sense, I hope. And so the actual picture for the complement would just have one ball. So here's U, here's the universal set, and here is A. And so A complement is this is everything that's in A but not that's not, it's in U but not in A. Hey, it looks kind of groovy, I think. It'd be a cool flag. Versus our country. I'm gonna do that. And notice that this right here is, this A complement business is really the only reason we need to mention U at all. Just because we have to kind of know what's our bounds. Because if you just want to write A complement, if you just want to say everything not in A, well, once again, what's the universe we're talking about here? Like if A was 1, 2, 3, and you want to do A complement, well, what's our universe? Are we saying we want all real numbers that aren't 1, 2, 3? Or are we just talking about rational numbers? Or are we just talking about natural numbers? Or are we talking about complex numbers? Or like, for example, like would the matrix 1001 be in there? I mean, 1001 is not 1, 2, or 3. Right? So this is why you need a universe for your complement to tell you just like where does it stop? Where does it end? And so, for example, if U were to equal the set, if U were to equal the natural numbers, then 1, 2, 3 complement, well, that'd just be every natural number that's not 1, 2, or 3. So that'd be 4, 5, 6, 7, 8, on and on like that. But if U was the real numbers, and we're looking at Q complement, What would this be? What's the name for Q complement? How would you describe elements of this set?
Would that just be the irrational numbers?
Exactly what the irrational numbers are. Yes, thank you, Taylor's iPhone. Yes. These are just the irrational numbers. This is all it means to be an irrational number. Being an irrational number just means you're not a rational number, which is exactly what it means to be the complement of the rationals. That's what it is. We say complement like they complement each other, like ever seen a rom-com or something like that, or just real life where two people compliment each other, and like it's like he's really into sports, she doesn't like sports at all, or whatever it is. Like he's a slob, she's neat, she gets the house nice. They complement each other, right? They fill in each other's gaps. That's exactly what complements do, because we should note that A, if U is our universe, A union A complement always equals U. Think about it, right? This is a complement right here, or the purple is A complement. The red is A. You put A and A complement together, well, that's all of U.
So if we put in words, it would be A and not A.
Yes, although I don't love the word and to describe a union. So I'd say A union, not A. The reason I like the word and for union, I see what you're saying, is because really, in a certain sense, unions almost have more properties of or, because it's kind of like if you're looking at it as the sets, then union's kind of like, yeah, it's this set and this set. But if you're looking at it like which elements qualify to be in A union B, well, the elements that qualify the elements that are in A or in B, and union really has a lot more quality similar to or than and we'll kind of see that later. But yeah, you're totally right. A union A complement is just whatever university came from. So